Okay, why don't we make a start? Good evening, everyone. My name's Anna Stevenson. I'm the Heritage Education Coordinator for the Bermuda National Trust, and it's my pleasure to welcome you here this evening for another one of our Trust Talks. This evening, the topic is palm nutrition, the 17 essential elements, and our host this evening is Stephen H. Brown, who is Horticulture Agent for the IFAS Lee County Extension Parks and Recreation Division. The presentation will help you to identify the most common deficiencies and ways in which to correct them. So without further ado, I'm going to hand over to Stephen. Good evening, Stephen.
Well, thank you, Anna. I'm glad we're recording this because I have a lot to go through, and I have about 40 minutes. So at the very end, let's ask some questions. So it's entitled Nutritional Deficiency and Fertilization of Palms. And there may be 17 essential nutrients, but as far as palms are concerned, we only need to look at 4 or 5, and today we're going to look at 5. They include boron, manganese, we have potassium, and we have magnesium. And a lot of these nutrients are affected by pH, and it depends on the pH range of the soil, then this nutrient is either available or unavailable. So for boron, we generally have availability below pH 7.5. For manganese, below 5.5. Both of these elements, by the way, are what we call micronutrients. The palm or any plants don't need them in great quantities. The other 2 nutrients, potassium and magnesium, they are what we call macronutrient. Potassium is, should have corrected the 6 on the other side, but above 6, it becomes more or less unavailable, and magnesium above 6.5 and above 7.5, it becomes unavailable. Okay, one thing we need to look at for the micronutrients that we're looking at, these 2, boron and magnesium, the first symptoms occur in the new leaves. So boron, if you look up and the symptom is just began, you will see it in the new leaves. For potassium and magnesium, and again, these are the macronutrients, meaning the plant need these in greater quantity to do well. The symptoms will first occur on the older leaves. In all cases, when the symptoms become so severe, the entire canopy can be affected, both old and new leaves. So, So again, just as a reminder, you see the pH is there. pH is there where they may be not as available. So reason for boron deficiencies, not just, by the way, it's not just pH, but if the soil is low in organic matter, and we have low organic matter here in the sandy soils of Florida, and that's another reason too why a plant might be, or a palm might be boron deficiency, is that the soils are sandy. And here we live in a humid region. Our rainfall here in where I am in Southwest Florida is approximately 55 inches per year, which is probably equivalent perhaps to what you guys have per year in Bermuda. I'm not sure what kind of soils you have in Bermuda, but I don't think it's as sandy as it is here. So with sandy soil throughout the world, we usually have low organic matter. And boron is also associated with drought periods. And in Florida, during the spring, it's very droughty. So from November through about May, or October through about May, we really have essentially, that's our low rainfall period. And even if the pH is good, there might not be enough boron available at times because it comes and goes, even in the soil. So what are the deficiency symptoms? There are a bunch of them for boron. Number 1 is a small crumpled new leaves with corrugated or accordion-like leaflets. Easily identified. Also, number 2 is tightly fused new leaves, and we're going to see some example of all of these. So the entire new leaves are not opening up all along the length of the leaves that are trying to open up. Their fuse from the tip to the base, or sometimes the tip may just open. The rachis, which is the center part of a fan palm, is devoid of leaflets. And the entire crown may be bent in one direction. That's very telltale sign. Additionally, the death of the meristem, meaning no new spear leaf occurs, death of older leaf and the spear leaf, and we have asymmetrical leaf base and on petioles. So let's take a look at some of the symptoms right here. This is a small crumpled new leaf. This is a Bismarck palm, and you can see right here how crumpled the leaf is. See right there? And this is a new leaf. As it emerges this way, and it will be forever deformed. This is a queen palm. If you take a look here, you can see the corrugated leaf, and the leaf has not fully emerged, and you can see right here, it's all crumpled up. This is a corrugated effect, or the accordion-like leaflets. So that is a big symptom of boron deficiency. Number two would be the new leaves that are unopened. Now, these are two Pygmy Day palms side by side. The interesting thing about nutritional deficiency of many palms, you can have a palm right next to another palm. One look relatively healthy, and the other may be suffering from a nutritional deficiency. In this particular case, this symptom states that the entire length of the new leaves are fused. So the new leaves appear in the middle, the older leaves are down here. But there was a period in time when maybe droughty condition or some condition, and it may have nothing to do with pH, that affected this particular palm, causing boron deficiency and the new leaves not to open. Now here's a foxtail right here, and you can see that this has the same symptom. The older leaves are here, and the newer leaves are just not opening up. Actually, this symptom is pretty easy to cure, a couple of ounces. And remember, boron can be toxic even in a low concentration. So if you're going to apply boron, follow the label and only apply a minute amount no matter what, because you don't want to have toxicity. But in any case, this particular symptoms can be resolved by boron application. Now here is where the leaf tips are devoid of leaflets. You can see it's right here. And over time, the new leaves become older leaves, and this is what has happened here. So the entire canopy can be affected. And this is number 4, the example of a bent crown, bent in one direction. This is the royal palm, and as you can see, the crown is bent over here. This is a very telltale sign of boron deficiency. Let's look at another palm with the same symptom. This is your queen palm. You can see it is fruiting at this time that I took the picture, but the crown is also bent over. If left alone, this can actually kill the palm. The crown will continue to decrease, get brown, and it will finally kill the palm. Now let's again, remember I said we saw the example with the 2 Pygmy Day in which one palm was affected, one wasn't, boron deficiency. Here you see an affected palm with boron deficiency with the bent crown, and the other 2 palms on either side are not affected by boron deficiency. So that's pretty common, as I said, with many palms. So let's take another look now, the death of the meristem or the spear leaf. So this is a Washingtonian palm, and this particular case, let me jump ahead right here. This is the palm from which it came. This palm had no spear leaf, so what I did was I cut open here. The palm fell. When it fell, so the entire palm is now dead, we cut open here, and the meristem is the new growth where the new leaves appear. And remember, for solitary palms with one trunk, they only have one growing point, which is at the very top of the trunk. So here it is right here. You can now see this would have been the spear leaf, but it never emerged because the top of it is infected with, basically it's boron deficiency, and you can see the accordion effect on this particular leaf. So boron then kill this particular palm, this Washington palm. So as you can see, what did we look at? We look at Bismarck, we look at Pygmy Day, we look at foxtail. Now we're looking at Washington palm. So it's pretty common in a variety, many different types of palm. We also did look at queen palms for this too. So that was that taken out there. Death of the older leaves and spear leaf. You saw the spear leaf dead in the last palm. These are again Washington palms. The palm on the right on the left, that is affected by boron deficiency. We took the palm down, examined the leaf, and there's another typical symptom of boron deficiency. The leaf base may be asymmetrical, so we have an asymmetrical leaf base. If we further take a look at the leaves, some of the Washingtonians should have teeth on the petiole, but in this case, there are no teeth on the petioles, so the petioles are unarmed. And if this product is available, and there are other products which are probably about 40 or maybe more % boron in it, you can use 2 to 4 ounces per 5 gallon, drench it into the soil under the palm canopy, and do not repeat for at least 5 months. And you know, in truth, sometimes it takes a year, year and a half for you really to notice the difference. The correcting nutritional deficiencies in palm is really a slow process. So let's look at the other nutrients. We're going to do 4. This is manganese deficiency, and availability decreases as the soil pH increases. So with manganese, this is another micronutrient, and increases in alkaline soil with high undecomposed organic matter. So what we're saying here is not only if the pH is high, but if organic matter in the soil is not decomposed, manganese is going to be less available, because many of the plant nutrients comes from decomposed or organic matter, humus. And if there's not enough of that, quite often the palm become deficient because there might not be enough that is given back from the soil minerals. So it can also be induced during cold, wet weather. And we do have in Southwest Florida, occasionally we have freezing temperature. So it would be below 0 centigrade or 32 below Fahrenheit. So we do get that maybe once every 6-7 years, or maybe a little less, and doesn't last long. And we have this condition, manganese deficiency, does increase on the very dry condition. And as I've said before, we have a distinct dry period in Florida, which would be in the winter and late fall, winter, and spring months. So manganese deficiency symptoms, well, what are they? Number 1, you have emergent leaflets are yellow or chlorotic. Number 2, this is a big one. You notice that I have blocked it out in yellow. The leaf tip, and again, this is emergent leaves, the new leaves, the leaf tips become necrotic, that means dead, withered, and curl, otherwise known as frizzled top. And growth stops, and all new leaves are frizzled, and then the palm dies. So the next slide will be of 2 palms that are in a roadway medium. And in Florida, much of this type of soil where they brought in soil to elevate the land, because remember, Florida is basically almost all at sea level. So to get it up to code or to grade, they usually elevate any new roadway or housing construction, as you can see across the road. When they do this and bring in what we call fill material, in Florida, that's usually a pretty high pH, going up to 8.5, 8.6, which is not unusual. Florida native soil is usually about between pH 4 and pH 6, so it's fairly acidic. So this palm here is a native palm. It's native to the royal palm. It is native to the Caribbean as well as South Florida and it likes dampy acidic area. So you put it in this, and look what happened. What happens? It's growing in a roadway medium and not much decomposed organic matter that can be released as manganese for the soil root to pick up. So if we take a closer look, we see that this is frizzled top. Not only is this frizzle right here, but this other leaf that came before it is slightly frizzled. The newest is frizzled. The oldest are not frizzled, and the oldest may have developed in a nursery before being planted in the roadway. The palm on the right here, this one is completely frizzled out, and this is what happens. They're in this condition, and then over several months, they become much like this, and the palm at that point is basically a dead palm. So here's a picture of a completely frizzled royal palm, the entire canopy. And you notice for this particular palm, much of the leaves are lost, so it doesn't produce new leaves. And the palm eventually dies, as in the queen palm on the right. So you see in the dead palm here on the right, you see a lot of older leaves that were not manganese deficient. The newer ones were right here. They developed that frizzle top. Over time, the palm dies. Of course, if that happens, the older leaves also will die. So there you go. So treatment for manganese deficiency. The recommended fertilizer is an 8-2-12-4 analysis. 8 nitrogen, 2 phosphorus, and 12 potassium. This is the percentage in the formulation, and 4 magnesium. Now, in truth, I think it depends where you are, because this analysis or formulation can be hard to find even in Florida. It's not available everywhere. And I think if you're having a palm deficiency problem, something that contains any of these nutrients would probably work if applied wisely. And with regards to this 8-2-12-4 application, we recommend about 4 applications per year. And that could be dependent on the size of the palm. It may be as much as 6 pounds per palm, or 6 pounds per 100 square feet or thereabout, or less if the palm is smaller. So let's deal with now, we have just left manganese deficiency, and now we're on potassium. So reasons for potassium deficiency. Number one, it's typically abundant in soils, but only a small part is in a water soluble. It's soluble enough that the palm roots or the plant roots can take it up. So it's usually available. And we have a lot of potassium here in South Florida, believe me, a lot in the soil naturally. So low soil pH, it's usually deficient. It may be in the soil abundantly. And when we say at low soil pH, at this acidic range, it may not be, it may still be in the soil. It is still in the soil in abundance, but the chemical reaction in the soil prevents an uptake by the plant root under these acidic conditions. Another reason why you may have potassium deficiency is compacted soil. And when you put in new houses, you put in new roadway, you have to press down on that soil, compact it to form a solid base. When you do that, you squeeze out the air, so you have a deficiency in soil air. And remember, soil air is essential for plants to do well, because they have to take up oxygen, they have to take up carbon, and they have to do a whole bunch of things within the soil air. So when you have a new site and you compact the building site, you can squeeze out the air, and you can cause poor soil drainage or waterlogging problem. This can cause mechanical injury to the plant, and root decay. So these are reasons why you may have potassium deficiency. And with root decay, you may have a boron deficiency. You may have some other deficiencies. So sandy soils have the lowest content of potassium, but even clay soil can be depleted where quantities are removed from when farming. So sandy soil with low pH can. So potassium deficiency symptoms, mild to moderate deficiency. Here we go. What are they? It starts in the older leaves. Remember, I said potassium and magnesium, which are the two macronutrients that are of most concern to us. The deficiency symptom starts on the older leaves. With boron and with manganese, these are macronutrients, the deficiency symptoms, not usually, but almost always starts on the new leaves. So we're looking at these two macro starting the deficiency symptoms on the older leaves. The leaves here, second moderate symptom, leaves become mottled. It means a lot of little yellow translucent spots. They're necrotic spots. And marginal or tip neurosis with little or no spotting present. So here's an example. Well, here's an example right here. This is a coconut palm. And what we see here are the leaves are mottled with yellow translucence or necrotic spots. And the next slide is of a Pygmy Day Palm, and you can see the marginal tip necrosis. So what we're saying here is this is yellow and or not as green as it should be, but the giveaway is the tip of this leaflet, they're all dead, they're necrotic. And this is a sure sign caused by potassium. And of course, this is on the older leaf, as you can see here. So you have marginal or tip necrosis. So they're all dead all along the tip, really from the top, from the base to the tip right here. And the next one here is of a royal palm. The rachis and petiole usually remain green. That's another symptom. So you can have here in this royal palm, the older leaves you can see are affected. Here's a leaf that is newer, not yet affected. And if the deficiency continues, this too will become affected. But let's look at this older leaf here. We can see necrotic or tip necrosis of the older leaf. But the rachis, which is this right here, that center portion, usually remains green, as it is here, but not as green as it is in this case. So severe deficiency, the entire canopy, so we're going from moderate, mild deficiency to severe deficiency that is caused by potassium. The entire canopy has a few leaves, all will be chlorotic, frizzled, and stunted. So the canopy actually begins to don't grow enough leaves, doesn't produce enough leaves. When I drive around and I look at palm, a healthy palm will have more leaves than you think it should have. If you see a palm and the leaves are kind of scanty, that means something is wrong with the palm. It should have more leaves and fuller leaves, a fuller canopy. In this case, potassium deficiency, the entire canopy has few leaves and they will all be chlorotic, frizzled, and stunted. The crown shaft and trunk appears tapered. They will be tapered. We call that pencil pointed. So the crown shaft and the trunk will be pencil pointed. So let's see those right now. So what we have here, these two are royal palms. We have the crown shaft right here. It's becoming skinnier. You can see the older leaves right here are affected by potassium, very classic symptom. We have fewer, in this case, fewer leaves. In this case, we also have fewer leaves right here. And you can see the leaves are becoming stunted, shorter. We still have the spare leaf, but these are two examples of potassium deficiency within this particular royal palm. So here's another look. Here we see severely deficient, and here we see 3 that are deficient. And over time, the crown shaft will become so skinny, this being the crown shaft, where the leaves are being formed, that the canopy will become so small that they will fall off onto the ground because they are not supported. The canopies are not supported. And this is again one of the better example of potassium deficiency. And if you watch this, it may take about a year for all of these symptoms to get that severe and to be completed. One thing I highlighted here is that too much potassium in the soil can also reduce magnesium availability. So if there's a potassium deficiency, we recommend that you also apply magnesium to the soil, because too much potassium in the soil will reduce magnesium. So we usually make that recommendation simultaneously apply a magnesium source along with a potassium source. So correction of potassium deficiency, broadcast is 8-12 for magnesium at that rate, 1.5 pounds per 1,000 square feet. As I said, sometimes, you know, you can bring it up to much more than that. Fertilizer should always, if you can, be 100% slow release nitrogen, phosphorus, nitrogen, potassium, and magnesium. And for severe deficiency, again, use a control release, meaning a slow release potassium sulfate, and simultaneously apply 1/3 as much slow release magnesium to prevent a magnesium deficiency. Broadcast all of this onto the canopy at about 1.5 pounds per 1,000 square feet, and you can repeat that in about 3 months, 4 times a year, and you keep going. Reason for, and here's the 4th nutrient, reason for magnesium deficiency. What are they? Soil too acidic or too alkaline. So there's a narrow range here, but other things can affect it, right? Remember we said for some nutrients, compacted soil. For some other nutrients, it could be flooding, as with iron is a good example of that. Also, for magnesium deficiency, it occurs more frequently in sandy soils as opposed to clay, thick soil. Heavy rainfall, and we have sufficient rainfall here in Florida that we call it heavy rainfall, particularly in the summer months. We probably get at least 60% of our rainfall, maybe more, during the summer. Then you have potassium-rich soil. We've already made reference to that. Potassium-rich soil is a naturally occurring event here in South Florida, and that can automatically mean not enough magnesium is being taken up. As a matter of fact, in Florida in general, one of the biggest deficiency for plants, it doesn't matter what they are, gardenias or bougainvillea, it is generally a magnesium deficiency caused by too much potassium in the soil. And as I said, the potassium is naturally occurring. Infrequent or ineffective fertilization. And magnesium deficiency starts again with the older leaves. The bottom leaves are affected first. And in feather palms, broad chlorotic bands along the margin with a central portion of the leaves remaining distinctly green. And finally, in fan palms, the chlorosis may appear as broad yellow bands along the margin of individual leaflets or the leaf as a whole. So symptomatic leaves will never recover. And this is true with no matter what palm or no matter what plants. Once the symptoms appear on the leaves, they'll never recover. They have to fall off, new leaves reemerge that are well treated and will not become symptomatic. Now, magnesium deficiency is rarely fatal in palm. So it will persist on a palm for years, for generations. If the palm live 100 years, you may see that magnesium deficiency, but it doesn't kill the palm. So here's an example typically of magnesium deficient palm. So if you look at these Canary Island date palm, we have two along here. They both are affected right here. The bottom leaves, you see the bottom leaves here, are affected first. The top leaves look green. So these are pretty severely magnesium deficient. And again, we call these feather palm because they do kind of look like a feather as opposed to fan palms that look like the palm of your hand. So in feather palm, broad chlorotic yellow margin with the central portion remaining distinctly green. So let's look at another palm right here, and you can see the same symptom. So there's a chlorotic or yellow margin here. The center is green. You have yellow margin, but the tips of the leaves are not necrotic as they are in potassium. You remember that, potassium deficiency? So here you have the margin of the leaf, well, the bottom of the leaf are affected first, the center remain green, and on both sides of the center, the leaf is yellow. So let's take a closer look at that palm. So you see the green here, the yellow band on both sides. And in this case, you really don't see any dead leaflets tip as it would be in potassium. But over time with this deficiency, it will cause some of the older leaves to die back, as you can see on the other side here. So here is a Pygmy Day Palm, and this Pygmy Day Palm have the tips, the potassium deficiency, going back to the previous slide that we saw before, the potassium deficiency on the lower leaf. This is a Pygmy Day Palm, and as a comparison, we're back with the magnesium deficiency on the lower leaf of a Canary Island date palm. Now, they both can have the symptom simultaneously. So you can have a palm, a leaf that has simultaneously, it has potassium and it has magnesium deficiencies. And we can see it in the next example right here. So this palm has both potassium and magnesium deficiency. You can see the yellow band. You can see the leaf tips that are dead. So this then is both a potassium and a magnesium deficiency. And that is why we want to balance out the application of potassium with a magnesium application as well. So mild to moderate deficiencies, how do you correct them? In neutral to alkaline soils, use magnesium sulfate, and again, preferably the less soluble kieserite or another such form. And again, routine application of the A212-4 magnesium maintenance fertilizer. In severely deficient soils, we have supplement with the regular A212 broadcasted around, and stagger regular and supplemental application by 6 weeks, and this may take 2 to 3 years to correct. And again, for all of these palms, the leaves may be, if a leaf is affected, it will never be cured, it will never get better. And we also tell you, don't cut off the leaf, even if it looks tacky, until it is almost completely dead, because these leaves may have the ability to continue to photosynthesis. And if you cut the leaf too early, then this, especially the bottom leaves, if you cut them off too early because you see a symptom, then that particular magnesium or potassium deficiency in the older leaves will now quickly jump to the next leaf in line above those, because the palm is now pulling magnesium, not enough from the soil, so it takes it from that older bottom leaf, and so you're accelerating the deficiency symptoms when you cut off the older leaves. So keep the older leaves on as long as you can, and then remove them when things get too aesthetically too bad for you to stand that. So I think I've taken about half an hour or whatever time I was allotted. And I just want to mention right here that if you want to contact me, I do have an email address, which is brownsh@leegov.com. And you may want to join us on the Lee County Extension on Instagram, Lee_UFIFAS. And I do a lot of posting of flowering plants that I'm sure we have in common with Bermuda and other places throughout the world that grow such plant. So I can go on if I wanted to, but I see it's 5:37 now. I'm supposed to be done at 5:40. If we have any questions, I'll be happy to take them.
Thank you, Stephen. So if anyone has any questions, type them in the chat or take yourself off mute and Stephen can answer them for you.
Dr. Brown, I have a question. Our landscape gardeners here in Bermuda have a habit of completely denuding palms all the way up so that they just appear as a fountain. And it's one of the most depressing sights I can ever see. So I'm delighted to hear that you recommend keeping the leaves on. I think the leaves, the leaves until they're dead, surely the palm is taking nutrient out of those dead leaves and putting it into other parts of the palm. I just think cutting off live green leaves it's terrible.
Yeah, and you know, they do this practice here in South Florida as well as an annual ritual, and it's called the hurricane cut. So right. Essentially in April, May is when they begin to do this. As a matter of fact, it doesn't matter how much we preach about this, it's always done, because if you think about it, the two things that are, one big thing that are pulling this, or the couple of things, would be people fear of hurricanes and that these leaves are going to be thrown around, which actually quite often they're not thrown around as much as you think. And secondly, they do charge when they do make these annual cuts. And they're not cheap to be cutting the leaves off coconut or sable palms. And I know we have a sable palm here just routinely, and they really cut that back. But I've been through, and the sable palms are in the back. That's the national or the state tree of Florida behind me in the background. And we can have a category 4 hurricane, and essentially not one of those leaves will fall off, even through category 4. And you're quite right. We say keep them on, because what they do is they photosynthesize up until the very end. And you know what photosynthesis does? It provides food for the plant.
Keep preaching that message. It's so
yeah,
important.
we will. Any other question?
I have a question, Dr. Brown. Thank you.
Actually, I have to correct you all. I'm not a doctor. I do have a master's, but I'm not a doctor.
Mr. Brown. Yes, thank you. I have a row of 3 palmettos, and from your description, I think the center one is definitely suffering from potassium deficiency. It's got a sort of mottled yellow and sort of dead leaf tips. But interestingly, the ones either side are perfectly healthy. What is the explanation for that? I mean, you described that before, where you could have a perfectly healthy palm next to one that's suffering from a deficiency. It seems odd that the soil should sort of have these deficient patches.
Yeah, you know, that's a really good question, because you'll observe this quite often where you see palm planted in a group of 3s and one is dying and one isn't. But one explanation may simply be root competition, because some plants, especially being that close to each other, their root system will overtake another root system and squeeze that one out of nutrient. The root system of palms, unlike a lot of the hardwood, they don't fuse. So they don't help each other out. They're all each palm for themselves. And I've looked at some flowering trees, and many in particular, and quite often they tend in a group to flower simultaneously. And that could be too because they're sharing substance through their roots, because their roots are often grafted. The roots of palms are very competitive. They don't graft. They almost seem always to be fighting with each other. So the weaker one does not survive. That would be my best explanation as to why this occurred. You notice when we had the royal palms, we had the boron deficiency, and we had two palms on both sides look pretty good. The one in the center wasn't. That one in the center may just be outcompeted by the other two on both sides. That's one explanation. I'm sure there are others.
Thank you. Yes, so palms are basically selfish trees.
They're selfish beings. And you know, I've spoken to quite a few nursery people in order to, and that's why we recommend fertilization, especially on our poor sandy Florida soil, because fertilization will help the other palms to compete with the stronger ones.
Thank you.
You're quite welcome. Maybe one day I'll be back in Bermuda, hopefully sometime within the next 4 or 5 years, who knows?
I know this is being recorded. Can the Trust let us know where it is? Because this is a sort of presentation one would like to dip into as you find your yellowed and necrotic tips, and you want to know which of the 4 elements it is. So I'd appreciate knowing where we could find this, please.
Yes, we'll put it on our YouTube channel, and then we'll be sure to send it out to everyone that was on the call tonight.
Perfect, perfect.
Yeah, and one more push from for our Instagram. If you do have it, you can see the address for it right below. So, well, thank you very much. And by the way, have a good night and a good weekend. And again, maybe one day I'll see you. And I do talk on other subjects.
Thank you very much.
You're welcome.
Stephen, have a nice night. Thank you, everyone.
Thank you.
Thank
Good
you.
night.